All right, so we are here in geometry. We are on lesson 16-4, graphing quadratics, vertex form. Our quiz is what? Tomorrow on Friday. Yeah, so today's date, April 25th, 2019.
Is there a filled copy online?
Not yet. All right, so vertex form. This is vertex form. It is really nice to find the vertex, yeah. There it is. Let's talk about some things that's going on with our vertex form. This A, this affects the shape. So I'm going to use the word shape here. Can't spell shape. This affects if it's skinny, fat, etc., etc. Technically, it's called the vertical stretch. Or it could be a compression, I guess, if that number's between 1 or 0 and 1. So you're thinking of vertical stretch. So if I had a parabola that was made out of rubber and I could somehow stretch it up this way, that's what A does. A could squish it down like a compactor or could stretch it out if it was made out of rubber. That's what A does. All right, moving on to H. By the way, yes?
I don't know if it's a bad time or not, but I don't have notes.
You need to find them. I think Beverly's got them. All right.
Yesterday's notes then.
You should probably use today's note. H, this affects, so I'm going to do a shape here. The shape here is left and right. This moves the function left and right. And I don't like the word move because we're a little bit more technical than that. I'm going to use the word translate. Translate. And this doesn't mean translate English into Spanish. In math, it means move. Move left and right. So I'm going to do, in quotes above here, or to the right, this means move. Move in the horizontal in the horizontal direction. If I change H, the graph moves to the left, it moves to the right. That's all H does. It moves the graph. It translates the graph in the horizontal direction. So far, so good. And then finally, K. This also moves the graph, but now up and down. So I'm going to do this up and down arrow. Again, it's a vertical translation instead of a horizontal translation. Vertical translation. And again, if you don't like that word translation, you can call that move. It moves the graph up and down. All right. I'm going to wait for pencils to stop, and then I will move on to the next section. The most important thing you can take away from today is how to find the vertex from this form. The vertex is H, K. H, K. It's that easy. But there's a twist. Notice that in my equation I had minus H. What that means is this H right here will do an arrow. This H right here is the opposite of the one that you saw in the original equation, which means if I kind of skip down here to example 1, if I'm looking for the x-coordinate is not -1, it will be +1.
Right.
And then it'll be, the y-coordinate will just be -4. I don't have to change that one. So if I'm looking for the vertex of example 1, if you can remember this, you'll get XP. The vertex is 1, -4. I take the opposite inside and then just the regular on the outside. All right. Question?
If the H is positive, is it negative on the... So it flips both.
Yes, exactly. If it's negative, it turns positive. If it's positive, it turns negative. Okay. So if A is positive, I need to somehow write this down in words. I need a quiet volunteer. If A is positive, it looks like this. And if it's negative, it looks like this. Positive. Touchdown. Negative. Rainbow? I don't know. What are we going to say here? Ellery.
If A is positive, it opens up. If A is negative, it opens down.
Write it down. And up, I guess. So Ellery says up and down. Know that if it's positive, it opens up. If it's negative, it opens down. Right, Jaden?
Right.
Definitely. All right.
No, it's just asking Martina a mathematical question. Yeah, but I was saying it was 0. Mr. Still said
I think the answer is a rainbow. All right. I need to pull out marbles as well. Ellery has her marble. I already gave her her XP. All right, some review, and I have her card as well. I need to find the y-intercept. Some more review. What do I set equal to 0 to find the y-intercept? One person knows. Two people know. Two people. Going once.
How fast are
Going
we
twi-
moving right now?
Like on the Earth, like in the solar system, or through the notes, or like in our minds. I don't know. I'd have to Google it. Very, very fast. India, by setting what to 0?
You have to set x to 0 to find the y-intercept and y to 0 to find the x.
Write it down. Thank you, India. Marble for India. XP for India. You do the opposite to 0. Thank you, Sam. To find the y-intercept, you set x to 0. I will be asking you this over the next several days. You should have this in the back of your mind at all times. The y-intercept is when x equals 0. The x-intercept is when y equals to 0. Moving on to example 1. I promise you, if you can remember what the vertex is, you get XP. Raise your hand. What is the vertex of example 1? Colby's the only one raising his hand with a card. Go for it, Colby.
1, -4.
There it is. Write it down, everyone. The vertex is 1, -4. I switched, or I should say Colby switched the inside, he took the opposite, and he left the outside, -4. Again, the vertex comes from that inside, opposite, and then the regular outside. Thank you, Colby. All right, now the y-intercept and x-intercepts, just to get our practice in here. I'll switch colors here. The x, no, let's do y-intercept first. Y-intercept, I'm just going to abbreviate y-int. The y-intercept, what again do I set equal to 0? Someone set up that first line of the equation. Change it from a function to an equation. Beverly.
0 equals 4.
Careful. So what am I setting to 0?
The y.
I'm looking for the y-intercept, so what do I set equal to 0?
X.
So read off the function. I'll change this to a y for you. Instead of a g of x, I'll change this to a y equals...
4.
Yep.
Parentheses x.
Nope.
Wait.
Try again.
0
Yeah, there it is. 0. And then keep going.
-1 to the second power.
Thank you, Beverly. You can turn in your card. What?
You like
So, Beverly plugged in 0 correctly. That goes in for our x. And then I'm going to do some mental math here. We can do this all in one step. Are you ready? Oscar, head up. Here we go. 0 minus 1, everyone.
-1.
0 minus 1, everyone.
-1.
-1 squared.
Wait, 1.
1. Yeah, 1.
Negative times a negative is a?
Positive.
So, -1 times -1 is?
1.
There it is. 1 times 4 is?
4.
4 minus 4 is?
0.
So it just happened to be 0 also. Okay, so the y-intercept is 0. Just go ahead and write equal sign. That's 0. We did a bunch of mental math. That was kind of rude. Let's take some points away.
Wait, what? She thought it was funny. Come on.
Beverly, you choose.
You take it off.
Oh, come on.
Where's being rude? There it is. -1. You're back to 0. All right. Next, I'm on to the x-intercepts. There will be 2, 1, or none. We'll find out today.
All I said was be quiet.
It's not what you said. It's how you said it. All right.
I said, oh my god.
It's how your lips make the word sound.
So, from here, what am I going to do? Someone help me set up the first step. Read off the equation when I do that one thing that I just said right up here for intercepts review. What am I going to do? Say it louder, Aurelio. Set the y to 0. This is now 0, and I'm going to read off the rest of the equation. Also, Aurelio, go for it. 0
Equals 4x minus 1 squared minus 4.
Yay! Okay, thank you, Aurelio. Hey, Aurelio, you're back up to being positive.
Oh, you see that? You see that?
Good job. And you get a marble. All right, so from there, I now need to move everything on this right-hand side to the left-hand side. If you forget the order, look at PEMDAS. We're undoing things to X. We are going backwards. We're going from the bottom to the top. Quiet raise hand. What am I doing first? India.
Wait, let me do it first.
Yep, add 4 to both sides. I now have 4 is equal to 4 times X minus 1 quantity squared. I just added 4 to both sides. And I guess I can switch colors for each of these lines.
I really
Oh.
is a non-max kid. How many days do they have left?
Next, what am I going to do? Quiet raise hand. What am I going to do next? Martine, Chewy, Jaden, you can participate as well. Oscar, I haven't heard from you.
You square them or not? No?
Beverly, go for it.
You square them?
Do you divide?
You divide because the next thing in PEMDAS after addition and subtraction on that bottom rung right above Chewy's head is M and D, multiply, divide, undo any multiplication, undo any division that you see. I see multiplication. This 4 is being multiplied. I'm going to undo that, as Beverly said, by dividing both sides by 4. When I divide by 4, that 4 goes away, and this 4 turns into a 1. We divided both sides by 4. All right, so Martine, you're coming in sitting at the horseshoe desk.
Ooh, he said the D word.
Martine, come to the horseshoe desk.
He said the D word. Takes
I've been
me.
on that.
I'm going to go with off task. And you lost a marble. All right. What am I going to do to both sides? I now need to undo the exponent. I'm looking at E. I'm on the very top.
Square.
What am I going to do?
You square.
Ellery.
X minus 1.
Square root.
Ah, the square root. That is the opposite of the
That's the same
square.
thing.
It's not the same thing. It is the opposite. It is the inverse operation.
Okay, whatever.
And Ellery, the trick question on the left-hand side, I'm left with.
1.
That was,
Plus or
you fell
minus
in,
1.
you almost fell for it. Okay, darn. Yes, the square root of 1 is actually plus or minus 1. And on the right-hand side, I'm left with this x minus 1 because the square and square root cancel each other out. All right, and my final step here. What am I doing on both sides? Easy XP. Bev Cheetos.
Add to the negative 1 and then subtract.
There it is. Beverly and Ellery, let me get you both in here. Chunk and chunk. Gotta quietly raise your hand. Marble, marble. I'm adding 1 to both sides. I ran out of room. I'm gonna come back up here. I'm adding 1 to both sides. So I have this plus or minus 1 still left over on the left-hand side. And now I'm going to add 1 to it. Plus 1. And that will be equal to x. All right. I need someone to interpret that for me. It's actually equal to 2 things. What are the 2 different answers, and how did you get those 2 different answers, India?
When
I'm
you
sorry.
separate it out, you get a negative 1 plus 1, which equals 0, and then you get a positive 2 because plus 1.
There it is. There are our 2 answers. So x is equal to 0, x is equal to 2. There are our answers. Box them.
Okay, I think I got some XP there.
This is non-max.
Gotta quietly raise your hand.
Why?
Because that is the procedure. Sorry, I was calling on people too fast. I wanted to call on other people. Thank you, India. You got your marble, your XP. All right, I want to talk about the strategy here because it is a little bit hard. It's difficult to find some of these other points. So let's try to find the x-intercepts of this guy. Another little review. Oscar Hood. To find the x-intercepts, I do what? Quiet raised hand. Easy XP here. You're literally reading off of this over and over again. To find the x-intercepts, what am I doing? Someone new. Sorry, Beverly. Sorry, India. Someone new. Someone that still has their card. What am I doing to find their x-intercepts?
Yeah,
Oscar. 0 for x or 0 for y? There it is. 0 for y. Thank you, Oscar. Is equal to x squared plus 1. Oscar, I now have your card. Thank you for participating. And Oscar got his marble. All right. Now I'm going to subtract both sides by 1. Subtract 1, subtract 1. And I'm left with negative 1 is equal to x squared. I subtracted 1 on both sides. There's going to be a problem. The person that sees it is going to get XP. On both sides, I need to undo the square. Colby, talk to me.
You cannot have a negative as like something the answer to a square.
Excellent.
That was a little bit rude, Jaden.
What?
You cut him off as he was speaking.
Sorry, I thought he was done with the sentence.
That's even more.
You have it correct, Colby. So if I square root both sides, as Colby told us to do, the square and square root cancel each other out, and I'm left with x is equal to the square root of -1. But there's a problem. If I come over here to a calculator and I try entering, SQRT of -1, it tells me, hey, no. You cannot use photomath, and you cannot take the square root of a -1. Not until you hit Algebra 2. You are never allowed to do this until you hit Algebra 2, so this has no answers. This is what's graphically happening. You don't have an x-intercept. Everyone, draw a graph, a very quick sketch of a graph. Show me what's happening. How is it possible that you don't have an x-intercept? I'm going to walk around right now and see your graphs.
Nope.
All right. Those of you that had a parabola shaped like this, you are correct. I can just have it open up. It opens to the up direction and it's shifted up. It's vertically translated in the positive direction. This does not ever touch the x-axis. You can also have a open down parabola that's vertically translated in the negative direction, and it never touches the x-axis. If you don't have an example, draw it now. This is what's happening. Whenever you try to find x-intercepts and you get the square root of a negative, that is saying, hey, no, there aren't any x-intercepts.
No. Hey, you
No,
no.
Oscar, drop it
Exactly.
now.
No,
All right.
Oscar. What did the dentist say about chewing tobacco?
Why do I have to?
What
Why?
is negative?
That is very
Zero.
negative.
You are in trouble.
I think that's 2.
That is two.
Back to 0, lost a marble, all that stuff. Just don't. Okay, sometimes quadratics, Jaden, stop that, don't have what?
He says I need to get a vaccine because I couldn't afford it.
He did not say that. You stop also. Sometimes quadratics don't have what?
You just lied. That's another point.
An x-intercept.
There it is.
What's wrong with the
What?
non-vaccine?
X-intercepts.
Well, these are stuff.
Yeah, that's why my dad left.
I
I
know
don't
that's
care.
why.
Guys, do I just have to empty this jar? Will that make us stop?
Do it.
You won't do it.
I'm joking.
Oh my god.
Mr. Smith, what's wrong with my non-vaccine?
They're offensive. So, if they don't have x-intercepts, if maybe like half of them don't have x-intercepts, don't find them. I mean, if they don't work, then don't bother. I mean, some of them do, and maybe that's a good strategy. But for vertex form, don't find the x-intercepts because it might be a fruitless endeavor. So, what we're going to find is one thing. You're always going to find this one thing and then one random point. What is the thing that we always find for any graphing of a quadratic? You always find this one thing. It starts with a V. That's not it, Jaden.
Vertex.
Quiet raise hand is yes, Emily. There it is.
Why even bother, dude?
Got to get that
Why
procedure
did you
done.
bother? My god.
Because you have to quietly raise your hand.
Want to.
Emily, I can get your card. Always find the vertex and then one other point. All right, backside. We're on the backside of the notes.
I don't want to do it because I don't know how to do
We
it.
don't care.
I will teach you how to do it. All right, graph the function. I'm going to sketch this function.
Wait, what was the last one?
Vertex. Don't write vaccination. All right. Example number 2.
What's a fruitcake?
I'm going to find what point first. Quiet raised hand. Quiet raised hand. What point do I always find when I'm graphing a quadratic? Oh my gosh, I literally just said the same line like 10 seconds ago, and I have only 2 hands
It's
up.
1 and 2.
Colby,
-1 and 2.
the vertex.
I was gonna say.
You always will find the vertex for any quadratic. If you're not finding the vertex, you are not graphing the quadratic correctly.
1 and 2.
-1 and 2.
Quiet raised hand, what is the
No,
vertex?
I don't want to do anything.
It's plus.
Is there a quiet
plus
raised hand
1
over
and
here?
2.
Is it there like maybe a quiet raised hand in this vicinity over here?
One.
Oh darn. Oh yeah, Leo.
It's 1 and 2!
Negative 1 and 2.
Oh, Leo got it. -1 and 2. Aurelio.
Come on, he's provoking me. Look, read that. Please read that to me. What does it say? No provoking.
What does that say?
So in life, Aurelio, this is a lesson for all of us, not just to Aurelio. You guys will be provoked.
Yeah.
You are not allowed to. I mean, you can respond in a really hostile way to being provoked, but generally, you being provoked and acting on that provocation will make you get punished more heavily. Like Aurelio just got punished more heavily.
Oh! Did you see that? Who did that?
Jimmy!
What?
It was Jimmy.
Oh, it was not me. What happened?
No, wait, hold on!
No!
Everyone is responsible. I know that you feel that you might not be responsible for your peers. Make them stop. If you're being silent and you're letting them continue, make your peers stop.
Yo, what happened? I missed that. I turned around.
If you're letting me do all the enforcing, that's too much work on me. Help me out. If you're being silent, you are part of the problem. Everyone is responsible. Everyone is responsible for what just happened. Help me out. Help your friends. Tell your friends to stop. Starting from scratch. 0 marbles. Is anyone going to die right now? Someone heal Sam. You all are going to get minus 10 HP. Who can heal Sam real quick so she doesn't die?
Hello.
The cough comes in.
What a great example. All right. Sam, you can heal yourself.
Say it again, Mr.
Aurelio.
Mr. Sindel. Yo.
All right. You all just lost 10 HP.
Wait, what happened?
All of you lost 10 HP.
James,
Wait, I don't know if I think we're the same.
We're starting from scratch. Here we
Wait, did I
go.
heal myself?
You just healed yourself.
Okay.
All right.
I'm not trying.
We just found the vertex. Let's graph our vertex. -1, 2. As I walk around the room, I should see you graphing, as we said, on our front side. We're not going to find the x-intercepts because sometimes they don't work. We're going to find one random other point. Does anyone know of another point that we could use? Quiet raised hand. Who can think of another point? Oh, look, there's a quiet raised hand here. Yes, Aurelio.
The Y-intercept? No.
The Y-intercept. Let's try it out, but hold on. I'm not going to write this down because, actually, this will actually work. So I'm going to do the Y-intercept, and I will write it down. Aurelio, what is going to be set to 0 for the Y-intercept?
0 equals 3 parentheses.
Ooh, careful. So Y-intercept, just read it off of here. I'll give the notes for you. The Y-intercept is where? The Y-intercept is where? So read it off for me.
Oh. X.
Y equals?
3. Is it X -1?
So careful. The X has now turned into a
0 plus 1.
0 plus
0
1.
-1. Squared plus 2.
There it is. Thank you, Aurelio. And now, hey, look. We're making progress. We're starting again. All right, Aurelio, you're back to
Give me 1.
your positive points. Good job. All right. Let's do some mental math. Ready? You're going to call it out. 0 plus 1.
1.
1 squared.
1.
1 times 3.
3.
3 plus 2.
5.
Okay, our y coordinate is 5. Good job, guys.
That's good.
Let's add just a handful. This is 5.
Is that a Whoville hand?
The y-intercept that we just found is 5. Let's come up here to the y-intercept and mark that on our graph. Here's a cool little trick, too. I wonder who can get this. There is an axis of symmetry that goes through the vertex. There's an axis of symmetry that goes right here. That means that there's another point on the left-hand side that I can also graph. Who can think of it? I see 2 hands. I need more hands. I see 3 hands out of a classroom out of 17.
Would be 1.
Is there a quiet raised hand over here? Thank you, Sam. Colby, go for it.
-2, 5.
-2, 5. I'll do this in yellow. Because of the axis of symmetry, I also have the same point on the other side of this axis of symmetry. Now that I have 3 points, I'm ready to graph my, or at least sketch my parabola. Go ahead and do your best sketch. It's going to have to go through those points. And it's supposed to be curvy and not pointy at the bottom. There's our rough sketch. I said sketch, it's not a perfect graph. That's all I expect from you today. Again, as a review, what did we do? We took the vertex. The vertex is really easy in vertex form. Opposite of -1, opposite of 1 is -1. 2 is 2. Our vertex was -1, 2. We graphed it. We found 1 point. The second point, Aurelio had that great idea of doing the y-intercept. We did that. We plugged in 0 for x. We found that the y-intercept was 5, and then we used the axis of symmetry to find another point. Once you have 3 points, you are always ready to graph a parabola as long as one of them is the vertex. Our final example. This is the hardest possible example I can throw at you on the quiz, on the test, ever. This is the hardest example in vertex form. Again, I am always going to start with what? Starts with a V, quiet raised hands. I'm always going to start with, oh my God, I love this. Yes, Caroline. You're always, write it down. You're going to start with the vertex. You did. Caroline 50 XP, Caroline Marble. All right, what is the vertex with a quiet raised hand? Slightly less impressive. Oh, yeah. Is there a quiet raised hand though, Sam?
+5, -1.
There it is. Thank you, Sam. Marble and XP. Let's graph Sam's vertex. 5, -1. 5, -1. All right. This is going to be the hard part. So I'm going to use Aurelio's idea right now, and it's not going to work. Aurelio's idea is find the next point, which would be the y-intercept. My y-intercept, I know that this is a negative value. Is that opening up or opening down?
Rainbow.
Rainbow! Opening down. This is opening down because it's negative, positive, negative, field goal, rainbow. This is negative, which means my y-intercept is going to be somewhere down here. The problem is I've only given you to -10. This is going to be off the graph, I think. Let's check it out. So 0 goes in for x. 0 minus 5.
-5.
-5 squared.
25.
25 half, negative a half of 25. It's roughly,
12.
yeah, it's a little bit harder. It's negative 12.5. And then negative 12.5 minus 1,
-25.
negative 13.5, I think.
Yeah.
Negative what?
Wait,
I'm so-
wait, what? Isn't negative 12?
Don't write this down because it's not going to work.
Negative
I'll do this really quickly.
-1.
I have negative 1/2 times 0 minus 5 squared minus 1. All I'm doing is I'm plugging in 0. You're not writing this down. When I plug in 0, 0 minus 5 was negative 5. Negative 5 squared, negative 1/2 minus 1. Negative 5 squared, everyone told me was 25. It's a positive 25 because a negative times a negative is a positive, and I still have this negative 1/2 minus 1. Half of 25 is 12.5. Negative times a positive is a negative. Negative 12.5 minus 1. Nod your head, you're following along. From here, negative 12.5 minus 1 is the same thing as adding a negative 1. Negative 12 plus negative 1 is a negative 13.5. The problem is that this negative 13.5 is right here. It's off of your paper. So we're going to have to find a different strategy.
Wait. That's still y-intercept, right? So
Yes, you're
no
right.
matter what we do, it's going to be off the graph.
No matter what we do, the y-intercept is not on the graph on purpose because some of the problems that you'll see on the homework and the quiz are not going to be on the graph. Here is another way to do it. I'm going to make a table, x, comma, y. You are writing this down. We already found one of the points on this table. It was Samantha's vertex, 5, -1. I need to find another value, and I can choose any point. I can choose a point over here at -10. I can choose a point over here at 10. Any x value that you want. the x values that you should probably choose are really close to the vertex. This vertex is a x coordinate 5. Let's choose either 4 or 6, or maybe 3 or 7. Somewhere in the vicinity of that x coordinate of the vertex, those are the points you want to look for. All right, quiet raised hand. What should we try? What is our next x coordinate? Ellery, go for it. Let's try it out. 4. Everyone write down 4. We'll see if this works. It might work, it might not. Again, we're going to do a little bit of mental math. Are you guys ready to chant? Here we go. 4 is here. 4 minus 5.
-1.
-1 squared.
1.
Negative a half of 1 is
Negative 0.5.
negative half, negative 0.5. And then negative 0.5 minus 1 is...
Negative 1.5.
Yeah, it kind of came out bad. Should we try a different one? That's not a lattice point. It didn't come out to an integer. Let's try a different point. So we'll write down our answer. We had, this one was negative 1.5. It wasn't very nice. Let's try a different one. Let's go even farther. So Ellery tried 4. I'm going to go even farther to the left. I'm going to try 3. Even farther to the left. Let's see what happens. Again, we're doing our chant. So I'm plugging 3 in for x. 3 minus 5.
-2.
-2 squared.
4.
4 and half of 4.
-2.
And it's going to be negative as well. So -2. -2 minus 1. -2 minus 1.
-3.
There it is. Okay, write it down. -3. This is a lattice point. It came out to an integer answer, a whole number. We can graph that really easily. Let's do that. 3, -3. 3, -3. And before I sketch, I need a third point. Again, using that axis of symmetry. Where is it? Quiet raised hand. Where is that third point? I'm waiting until I see 5 hands. 1, 2, 3, 4. One more hand. 5. All right, Caroline. 7, -3. Everyone graph it. So our axis of symmetry was right here. So on the other side, we had 7, -3. And there are our 3 points. Go ahead and now attempt your sketch. This goes on and on forever in each direction. That concludes the notes. Make sure you have everything here written down.